So hello everyone, the next question is linked list cycle 1. Over here in this question, we will be given with one linked list where basically the last node, instead of pointing to the null, I mean there are possibilities where it can point to null, but instead of pointing to null, it can point to any of the middle nodes present in our linked list, and that will in turn make a cycle. Now our job is to iterate through this linked list and find out if there exists a cycle or not. If there exists a cycle, we return true, otherwise we return false. So with this, the return type is basically boolean. You just need to return true or false based on the availability or presence of cycle in the linked list or not. As simple as that. Now how can we do this? Obviously I cannot compare with the values, right? That if I just iterate and in a, for example, in a array or in a hash set, I keep on putting the values, right? And as soon as a value is repeated, then I say that the node is repeated. Now this would be a little wrong, because for example, what if the linked list that we are dealing with is something like this? It is something like this, right? It is pointing to null. So there are two elements that are present at different nodes. So these two are different nodes, but the value is same. So only by value we don't need to check. I need to actually check if the nodes are repeated. So the first node that would be repeated, there only I can say that a cycle is present. So if we are iterating through, so this 4 will be visited for the first time, then we visit this 5, 6, 7, 8, 9 all for the first time, and after that when we do next for once more, we get a repetition. Over here I can conclude that yes, there is a cycle. So at first it might seem very simple that I will be taking a temp pointer and after that I will just iterate the temp pointer. If this temp pointer reaches a null, I can say that there is no cycle. But if this temp pointer does not reach the null or it does not reach the end, then I can conclude that this is having a cycle. Now just think, if you want to deploy this approach, then how long would you wait before concluding that this is not going to reach a null? The linked list can be very long and you could have waited for very long and still the null did not come and you are concluding, but maybe if you waited for some long, then you would have gotten a null. That is a possibility, right? So there is no place where I could conclude that okay, after this I will not get a null, right? So this simple approach of just iterating through a single pointer, this won't work. As simple as that. So how can we do this? The best thing is we can obviously make a hash set. We can make a hash set because obviously hash set store all unique elements. Then what I can do is, before I will just iterate through this linked list over here and I will check if my hash set contains this temp. Obviously my hash set is now empty, it does not contain. So what I will do is I will save this, that maybe after in future I get another time this node, then I can check at that point of time that if this node has occurred, then it should be present in the hash set. So this is the way I can do. I can just proceed. First in my hash set 1 will be there, then 2 will come, then 3 will come. Similarly 4, 5, 6, 7, 8 and 9 will come. All of them before coming, they will check if that particular element is already present in this hash set or not. If it is present, from there only we can return true. But if they are not present, they will just be added in the hash set. We will keep on adding them in the hash set. And once the first element that is repeated comes, I can conclude that my linked list do has a cycle, otherwise the element would not have been repeated. As simple as that. So this is one approach. But over here it will take obviously order of n extra space, which is not desirable, right? We are doing it in one iteration only, but we are using extra space. So we must devise a strategy where we can do it without this extra space, right? We'll be talking about that, but let me quickly code this approach up quickly and let me show you, right? So what I'm saying is I will take a hash set which will be taking node list. Let me call it as hs equals to new hash set, right? And I will also take a list node temp for iterating through the whole linked list. I will assign it with head, right? After that I will tell my while my temp is not equals to null, then I can carry forward, right? And in every step what I will do is I first check, before putting anything in my hash set, I check if my hash set already contains the current temp. If it contains the current temp, I will return true from here. Otherwise I will just add the current element to my hash set. So I will add temp, right? And also I need to increment temp at every iteration, temp equals to temp dot next, right? Once we'll come out of while loop will mean that this condition has become true somewhere, so temp has eventually reached null. So in that case I can tell that I would need to return false because there are no cycles present in our linked list. So this should work, right? So it is list node, right? Sorry, right? So yes, this is working as well, this is beating all the test cases, but we need to optimize this, right? We will optimize this by taking no extra space and still doing it in one iteration, right? So how can we do it, guys? See, what I am saying is I will tell you the approach and then I will give you the intuition why this will work, right? Suppose this is your fast pointer. So don't think that the first and slow pointer was only used in calculating the middle of the linked list. This is a very strong concept which is used in multiple questions, right? Like in the next question also, linked list cycle 2, we will be using these pointers. So basically what I say is I will take the 2 pointers, slow and fast pointer, which are also known as rabbit and turtle pointer. So what I will do is my start will go for one step and my fast will move another step, okay? So my start will go and fast will be over here. After that start will be over here and my first will come over here, and in this manner when we iterate there will be a point over where my start and first both will be pointing to the same node, and at that point I can tell you that if they are pointing to the same node, they were incrementing in different steps, right? But if they are pointing to the same node, that means that my first has returned back somehow, and that is only possible if there is a loop, right? Otherwise my first would have reached to null. So this is the thing that we use in order to solve the question. Now you need to understand why does this happen, right? What I am saying is I will quickly code this up because the code is very simple. We will understand first what I am doing. So what I am saying is I will take 2 pointers, list node slow, I will assign it to head as well, and I will assign list node fast to head as well, right? Then what I am saying is that if the same thing, if my fast will reach null, obviously if there is a null, my fast will be the first one to reach over there because it is incremented by 2 steps. So if my first becomes, until my first is null, what I will do is I will increment my slow pointer once, slow dot next, and I will increment my fast pointer twice, dot next, right? And what I can tell you that obviously I need to also with this check that my first dot next is also not equals to null. We have covered this in find the middle linked list, because first dot next, if it becomes null at any point, then null dot next will give me a null pointer exception. So I need to check that both the things should not be null before allowing it to enter. So once after incrementing, because my slow and fast was pointing to the same pointer, I couldn't check at the beginning of this loop, right? I would need to iterate them once and then I will check that if my slow is equals to fast, then I am sure that there exists a cycle, I can return true from here. And if we move out of the while loop, that means either my first or my first or next has reached null. So if there is a null, then there are no cycle, then I can return false, as simple as that. This is what I am telling you, right? Let me quickly submit this and then tell you the intuition about this. So this is also running all the test cases, and this is also the first solution. Now let me tell you why does this happen, guys. So listen carefully. What I am saying is, suppose there is an infinitely long track, okay? There is an infinitely long track and you and your friend, both of you are running over here, and you take 2 steps at a time and your friend takes 1 step at a time. This is how you run, and let us consider that the track is infinitely long, okay? So what I can say is, if you are running behind and your friend is starting, like you might start from location 20 and your friend can start at location 3000. Then also if you are going by 2 step and he is going by 1 step, then and the track is infinitely long, then at every point you are closing the gap by 1 step. He is moving away by 1 step, you are moving towards him by 2 steps. So in total you are moving closer to him at every iteration by 1 step, because for example he was at position 10 and you were at 5. The difference between you both of you is 10. Now after 1 iteration he takes 1 step, moves to 11, you take 2 steps, you move to 7. Earlier you were at 5, you move to 7. So now the difference is 11 minus 7, which is 4. Earlier the difference was 10 minus 5, which is 5. So you are basically closing the gap by 1 at every iteration. So you are bound to meet that particular person once and you would be at same level, like you are decreasing the difference by 1. So it is not possible like that there is one gap between you two and after that you just move ahead of him. That is not possible. You will after the next iteration move to the equivalent place of where he was, and from 1 to minus 1 difference it will never happen. So I can say for sure, if this is the case, then you will come equal to your friend at a point before crossing him. Before crossing him, there will be a point when both of you will be at same level. This is what I try to conclude, because the difference is getting closed by one step at a time. And this particular thing is possible because your slow is moving by one step and your fast is moving by 2 steps. Because if, for example, your slow was moving by 1 step and your fast was moving by 3 steps, for example, then for example you are at 30 and your friend is at 31 and your friend moved to 32. Now what you will do is you will move to 33. So you are basically crossing your friend without coming equal to it. Then I cannot compare this particular condition over here, that my slow is equals to fast, because there can be a possibility when fast will cross slow without being equal to it. But when the steps are 2 and 1, they are bound to meet at a particular point. It will not cross without meeting, right? And but sir, you will tell me now that my fast pointer is running ahead. You are telling me that I am faster, I ran 2 steps and my friend is running 1 step, and you are telling my friend is running ahead of me. Now imagine that ultimately, obviously your slow and fast pointer will start from here. By the time slow reaches the starting point of the cycle, I am sure that fast has already made it to this portion and already crossed that. Now we are at this cycle over here and my slow is over here and my fast is over here. Now if the names were different, if these names were A and B, now and this is the only cycle that I have and I don't know what is the starting point. Now tell me who is ahead of whom? It is a circular track, right? I cannot tell that this pointer is ahead of this pointer. So I can consider that my slow pointer is ahead of fast pointer and my fast pointer is trying to catch up. And obviously the difference is 3, for example. Now after the next step the difference will be 2, because your slow will move over here, fast will move over here, right? So in every step the difference is getting decreased by 1 and there will eventually be a point where both of them will be same. So if you guys were in class, I would have asked you 2 things to give me 2 random numbers. First thing is in order to take how many nodes are present before the starting of the cycle, and another number to denote how many nodes are there in the cycle. Let us start with this only. My fast and slow would be over here. Initially my fast and slow will be over here. Then my slow moves over here, fast moves over here, right? After that my slow will move over here and my fast will move over here, right? After that my start will move over here and my fast will move over here. After that my slow moves over here and my fast will move over here. I'm moving by 2 steps and slow I'm moving by 1 step. Then my slow moves over here and my fast moves over here, right? And in the next step my slow will move over here and my fast will also move over here, right? And we are guaranteed to find these common grounds, like this common node where both of them are equal. Now I will just generate 2 random numbers. Suppose the first one is 1 and the second one is 4. Okay, so basically I will create a similar linked list. You can take any example at your end and try to dry run it. Suppose 1 and 4. So there is 1 node. After that only there is a cycle of 4 nodes, right? If this is the structure, this is the structure. So let me just dry run for this as well. Obviously my start and end will start from so my slow and fast will start from here. Then my slow comes over here, fast comes over here, right? After that, the second iteration, my slow comes over here and my fast comes over here, right? Next iteration, slow is over here and my fast moves to over here. Dot next is over here. And in the next iteration only my start will move over here and my fast will also move over here, and they are both pointing to the same node. So how much you make the cycle, it will always be valid. You can check it from your end as well. I already coded it up, guys. You can follow that. That's it for today, guys.